Hi there, I'm Aldo from Zero to Mastery, and in today's lesson, we're diving into the hottest thing since sliced bread, large language models. This lesson is from Scott Kerr's Prompt Engineering Bootcamp course, available on Zero to Mastery. So if you want to learn more about working with large language models, then click the link in the top right-hand corner, or check out the description below for the full course. All right, that's it from me. Let me hand it over to Scott. Enjoy.
Here we go. This is the section where we're going to start diving into some of the technical information on large language models. It's not going to be hard for you to understand this if you don't have a background in this sort of thing, because we're going to keep it high level. And because it's high level, I may take some liberties here for you hardcore machine learning engineers out there. But I think that to be great at prompt engineering, it's important that you have a fundamental understanding of how in the world this incredible technology works under the hood. Plus, it's important that when we use technical language, that we can be confident that we're talking about the same thing. It's always good to be able to use the right lingo when you're talking about something, right? So it'll make you a better prompt engineer to understand LLMs and to see how all the pieces fit together, while at the same time demystifying them a little bit. So let's jump in. First, I wanted to sort of break down the sector and where we are in it. You can see here I have this chart, starting with artificial intelligence is the big one, and then machine learning is a subset of that, deep learning is a subset of that, NLP or natural language processing is a subset of deep learning. Large language models are found here within NLP. And then we have prompt engineering, which you'll see overlaps with all of these, including large language models, but then also breaks off and is a bit of its own thing. That's where it intersects with basically every other field in the world. So let's break down this chart a little bit more so you can understand it, though. The key one here is this pink circle, natural language processing. NLP refers to the branch of computer science, more specifically the branch of artificial intelligence, focused on giving computers the ability to understand text and spoken words, the same way human beings can, right? It's got natural language right in there, and it's about processing natural language. They named it pretty well. And that's in contrast to understanding computer language, which is code, right? Well, that's not entirely true, actually. Computer language is zeros and ones. And an interpreter takes code and turns it into zeros and ones that the computer can then understand. But that's getting a little bit beyond what you need to understand here. I will include a link to a lesson from another course that you can take a look at if you want to understand this in more detail. But otherwise, let's keep going. The key thing that I want you to understand here is that until LLMs came along, machines couldn't really understand natural language. They could only understand computer language. And that ability to understand natural language is really important and what makes these models so easy for the average person to use. So if you are someone who actually wants to create large language models and conduct research into the development of artificial intelligence, then natural language processing is probably the field you want to be in, although there is some debate about whether NLP can ever actually become true artificial general intelligence. But putting that aside, for most people, the vast majority of people, you're not going to need to actually understand natural language processing. Instead, you're going to need to understand prompt engineering. That's the skill that you're actually going to need to use in your life and in your career in order to utilize the power of artificial intelligence. That's where the rubber meets the road. It's where all this incredible technology comes together to form something humans can actually use to do things more efficiently and effectively. So now that we have a lay of the land, let's jump into large language models specifically. And once again, they have named these quite obviously. These names aren't meant to be overly complicated. Once you actually break them down, it makes sense. So here we have LLMs, large language models. Why are they large? Well, the word large refers to the fact that these models are trained on lots and lots and lots of data, which is mostly text from the internet. And they have lots and lots and lots of parameters. We're going to talk about both of those things in this section. For now, just know that basically it's called large because it has lots and lots of the things that smaller language models have a fewer number of. Then language. This is referring to that natural language that we were talking about before. It's focused on natural language text. It's like speaking English as opposed to computer code. And then model. That one's pretty obvious too. It's a machine learning or AI model. So taken together, it's a machine learning model that is trained on lots of data and has lots of parameters. So therefore it's large. And it's focused on natural language. Pretty simple, right? All right. Now that you understand that, we can start diving deeper into the world of LLMs. So let's take a high-level overview now of the world of LLMs. So I have this table that highlights a lot of the popular models and chatbots that you've probably heard of before, but you might not fully understand the distinction between them. So I want to make sure you understand that before we keep going. First, there's a difference between the model and the chatbot. This language is often used loosely, which is why it may cause confusion, why you might be confused. So OpenAI is a company that has developed the GPT-3 and the GPT-4 models. They have then taken those models and they've put sort of a wrapper over top or like a skin. And that is in the form of ChatGPT. That's a website that allows you to use these models. And that's what a lot of companies do. You can see here, ChatGPT uses the GPT-3 and GPT-4 models. You can toggle between them. Bing Chat, which is Microsoft, uses GPT-4 model. The Bard chatbot by Google uses Google's large language model called PaLM. This one's a little bit confusing because they use the same name, but basically Anthropic is a company that's developed a model called Claude, and they call the chatbot Claude as well. And then Meta or Facebook has developed the Llama model, which is open source, meaning you can go and do whatever you want with it, really. So make sure you understand that distinction. There are models, and then there are chatbots, which act as a user interface to allow you to interact with the model. Now, I'm going to try my best throughout this course, I pinky swear, to use the right words in the right places. So if I'm talking about a chatbot, I'm going to talk about ChatGPT. If I'm talking about the underlying models, I'm going to say GPT-4. But guaranteed, I'm not going to do that 100% of the time. But the key is that you do understand the distinction between those. Now, before finishing up, there's one more thing that I want you to understand here. There are these domain-specific chatbots or AI tools. For example, we have Jasper AI and Copy AI. These use the GPT-4 model up here, specifically Jasper and Copy. They can use any model. There's all sorts of tools out there that are using various models, but I just want you to know that that's what's happening. They are using one of the models created by one of the big companies, likely. But more than that, sometimes they're using a slightly modified model. So for example, GitHub Copilot, which is an AI tool to help you with coding, it uses something called OpenAI Codex, which is a modified version of OpenAI's GPT-4 model that was then fine-tuned for use on programming applications. So in that way, there can be these specialized models that are specialized for specific tasks or domain areas. Okay, now that you understand the lay of the land or the world of LLMs, and you understand that there are models that underlie everything, and then they can be put to various uses through chatbots or domain-specific chatbots, now I think it's time that we move on and start looking at and understanding some of the actual technology that's in these models. And this is where it starts to become fun. This is where it starts to get really interesting, in my opinion. These last couple lessons are just sort of laying the groundwork so that we can move forward now and really start diving in. Okay, so in this lesson, we're going to talk about tokens. At a very high level, you can think of tokens as words, but that's just meant to help you understand it at a high level. There's a lot more to it than that. Tokens are the way that an LLM like GPT understands and speaks. You use words, GPT uses tokens. Importantly, though, each word is not a token. These LLMs break down words into smaller pieces, and those are the tokens. OpenAI says that one token is equal to about 0.75 words. But that's a rough number, and it's going to be different for each model. But it's a great guideline for us to use, so remember that. One token equals 0.75 words. Now, this is going to be really cool. Let's see how these words are actually broken down into tokens. Here we have the tokenizer. This is a tool provided by OpenAI that actually shows you how the GPT-3 model breaks down words into tokens. So let's start with a sentence here. She sells seashells by the seashore. And now at the bottom here, you can see there's all these pretty colors that have appeared. These colors show you the words being broken down into tokens. Each color block is a token. So this sentence contains 8 words, and that translates into 9 tokens. So that's just about the 1 token per 0.75 words formula. So that's great. Now, let's make things a little more interesting. What do you say? I'm excited to learn about prompt engineering. Also, I like pickles. That's true. I do like pickles. So down here with the tokens, there's a few interesting things that I want you to notice. First, it's interesting to see that the tokens actually often include the space in front of the word. So the token for the word excited actually includes a space in front of it. Same with the word to, and the same with the word learn. Each one of those is a token. Also, you can see that the word I'm is broken down into 2 tokens. I is 1 token, and apostrophe M is another token. You can also see that each period is its own token. And lastly, the word pickles is broken down into 2 tokens, pick and ulls. And this is really important to know and realize that many words are broken down into multiple tokens. And there's no real rhyme or reason that you, as a human, can understand how those words are broken down. You just need to know that they are broken down. In total, there are about 50,000 tokens used by GPT, and each one actually has its own token ID, a number associated with that token. If you click right here at the token IDs, you can actually see the token ID of each of these words. Now, let's do something interesting here. Let's go up here and add a second to. So I'm excited to learn. There you go, look at that. We have 284 appear twice. So 284 is the token ID for the word to. Now let's do something even more interesting. Let's add the word to, but with a capital T. And look at that. The number 1675 was added. So the token ID for the word to with a capital T is different from the token ID from the word to with a lowercase t. Okay, that's all interesting and simple enough, right? Now here is the really awesome thing, the thing that you really need to remember. This is the heart of what makes an LLM, well, a large language model. When you ask an LLM like GPT a question, what it's doing is breaking down your words into tokens. And then it's using a lot of fancy math and computer science to determine the sequence of tokens that are most statistically probable to follow your tokens based on what it learned in its training data. That's why some people call ChatGPT a word guessing machine. And to some degree, they're right. At its core, that's really what an LLM is doing. But really, when you think about it, at a very fundamental level, when you're speaking, is that all you're really doing as well? Whoa. Okay, let's not go down that rabbit hole just yet. So we just talked about how LLMs are essentially word guessing machines. Let's actually see what this looks like in action by hopping into the OpenAI playground. Now, I'm going to change a few settings here and we'll show you so that you're going to be able to change these settings and play around with it yourself if you want to as well. First of all, I'm going to go to mode and change this to complete. This changes the model so that it's focused on generating a completion to my prompt rather than a response. Then I'm going to go down here to show probabilities. I'm going to turn this on and change it to full spectrum. And then lastly, I'm going to go to this temperature setting. This temperature setting is something that we will talk about a bit later on in the course. For now, all you need to know is that this controls the randomness. So right now it's set to 1, so it's going to have middle of the road randomness. If you go all the way up to 2, that's going to be a lot of randomness. If you go all the way down to 0, it's going to be minimal randomness. Okay, now that we've got that all set up, let's input our prompt. I'm excited to learn. And there you go. It's completed my prompt by saying, I'm excited to learn more about the world of web development. Now, here's where it's really cool. When you click on these words, it's actually showing you the probability that each token is going to follow the previous token. So you can see here, I'm excited to learn, and it says the token more is 18.12% likely to follow those previous tokens. It could have selected other words, about, or \n, which is a new line, or how, or All of these had lower probabilities though, and we've put the randomness, remember, the temperature, down to 0. So what does that mean? It means it should be selecting the most probable token in each spot. And look at that, it does. Each token here is at the top of the list. How cool is that? Now, let's play with the randomness. Let's move the temperature up to 1. And then we're going to delete the completion here, go back to the original prompt, and hit submit. Okay, now you can see just by the color coding, there's some more red in here. That's more randomness. And so you can see the completion is a bit different as well. It's saying, I'm excited to learn, whereas before it said more about web development. Now it says all the things I don't know about web development. Let's go into the probabilities here. Look at that. It chose quite a random one. Very far down the list. It chose more originally up at the top here, but it's now chosen one way down the list. Here we go. This chose the second probability and a third. How interesting is that? Now, the cool thing is that even though there's some randomness here, this completely still makes sense, right? You can read it. And it says, I'm excited to learn all the things I don't know about web development. That's great to hear. Web development is an incredibly rewarding field that is constantly changing and evolving. It still makes sense. Some randomness is useful. And you can see this too if we change the temperature even further and make it even more random, up to 1.5. Let's delete the completion again, submit the original prompt. I'm excited to learn this language. And it says, that's wonderful. Language is one of the most enjoyable and stimulating pursuits. Now, this is starting to not make much sense, right? I'm not sure what it's referring to here when it says this language. So eventually the randomness can create issues. And you can actually see that if we go all the way up to the max randomness. And hit submit. So here we go. There's a lot of red here, which means a lot of randomness. And you can see it doesn't even make sense anymore. So it shows, first of all, after I prompted it with, I'm excited to learn, the word that it shows is Rex. RE is the actual token here, which only had a 0.01% chance of being the next token. But that's what it selected because I wanted the randomness. Now, XX is its own token. And again, super low probability. Java, you can see if you go just like the others, for the most part, it's choosing tokens that are near the bottom or at the very bottom of the probability. How cool is that? I absolutely love seeing these probabilities because this really allows you to see these word guessing machines working in action. Now, you probably noticed there, as we added more randomness, it became more casual, more conversational. When it was zero temperature, it's very formalistic. When it got higher, it became a more casual conversational tone. When it got too high, it became far too conversational. It became essentially gibberish. So that's something to keep in mind. But it's super interesting to see these models in action and how they're making these decisions. Welcome to the very first Thinking Like LLMs lesson of the course. This is a series of lessons that are scattered throughout the course where we're going to look at the edge cases. We're going to push the boundaries of what LLMs can do and sort of break them. And then we're going to deconstruct that to figure out what is going on inside these large language models that is causing them to give us some weird result. These are my favorite lessons in the whole course because I think it's super interesting to try to figure out what's going on inside these LLMs because they are such an incredible technology and they are a step towards artificial general intelligence, which we'll talk about a bit later. But also because it's going to make you a better prompt engineer because understanding what happens with your prompts when they go into these models is necessary to get the most accurate and effective outputs. All right, so that's enough on that. Like I said, I love these lessons. I think they're so much fun. Here we go. Drum roll, please. The first one is Thinking Like LLMs, roll a dice. So what I'm going to do is I'm going to hop into ChatGPT. All right, here we are. I'm in ChatGPT, and I'm going to prompt it with something really simple. Roll a dice. Now, before I hit enter, I'm going to use my mystical psychic abilities. And I'm going to say that ChatGPT is going to give me a 4. All right, let's find out. Look at that. Holy smokes, I can predict the future. If you're not amazed by now, then I don't know what to do about you, but that's pretty impressive, right? I can predict what a dice roll is. That's pretty amazing because a dice, as ChatGPT says here, has 6 sides, 1 to 6, and it's completely random which side it lands on, right? Right. Okay. Now let's hop over to the playground because I want to show you something. I'm a magician that reveals his secrets. So I'm going to prompt the model with the same prompt. Roll the dice. Wow, look at that. So it rolled a 4 again. What are the chances of that? I mean, a 6-sided dice, that's about 18% chance for any given number. And it rolled 4 twice in a row. That's not impossible, but unusual. Let's take a look here a little bit deeper and look at the probabilities of this and look at that. The number 4, that token has a 47.42% chance of following these other tokens. 3 has a 21% chance, 5, 14, 6, 14, 2, only 1%. This means that rolling a dice in ChatGPT is not random. Even though when I was in ChatGPT, it looked like it was totally random. It's not because remember, these are statistical models. They are calculating what token is most likely to follow the previous tokens. So now you're probably asking, why is that? Why is 4 most likely? Well, I don't really have an answer for you here other than that based on the training data that this model was trained on, 4 was most likely to follow the words or the tokens. The result is A. So I can't tell you why that is most common in the training data. Training data is a lot of information from the internet, for example. And I don't know why it's most common on the internet for people when they type out the roll of a dice, why they choose 4. If you have your own hypothesis on this, I would love to hear it. And also, if you're not totally understanding what I mean by training data, hold on, because just in a few lessons, we're going to dive deeper on that and learn about the whole training process of these large language models. But you probably already know the basics, which is that these models are trained on a lot of data. And for whatever reason, in that data, 4 is the most common dice roll. How wild is that? This is the stuff I love. You would never have known that if you were just in ChatGPT as a layperson and asked it to roll a dice. Let's actually try one more thing here. See if I can really stretch my psychic abilities. Okay, let's go. Pick a number between 1 and 30. And now I'm going to use my psychic abilities, hocus pocus, peanut butter and jelly sandwich. I'm going to guess that it says 17. Oh, I need to go play the lottery or something because obviously I can predict a lot of stuff. But no, as you can see, for whatever reason, when someone asks ChatGPT to pick a number between 1 and 30, it chooses 17 most of the time, 18% of the time, which is more than any of the other options. That is the statistically most likely token. There you go. So hope you like that. That is a really sort of fun edge case that exemplifies the fact that our incredibly sophisticated technology, but they are limited. They're not able to roll a dice and produce a random number. They're only able to produce the statistically most likely token. So go use this trick to show off to your friends. Although I do need to add a caveat to this before you go off and try to show off. Remember, ChatGPT doesn't always choose the statistically most likely token. It has some level of randomness, which might cause it to choose a different token, a different number here. But that's okay. Don't let that stop you from showing off to your friends.
And there you have it. A big thank you to Scott for guiding us through this lesson. Want to dive even deeper? Well, lucky for you, there's a whole lot more to learn in Scott's complete prompt engineering bootcamp course, linked in the top right-hand corner and in the description down below. Also, don't forget to like, subscribe, and hit that notification bell so you never miss out on future tutorials from Scott and other expert Zero to Mastery instructors. All right, keep learning, keep prompting, and I'll see you in the next one.